Ever wonder how a tiny little engine can crank out so much power? Or, how car companies keep promising better performance and better fuel economy at the same time? Well, a lot of the time, the answer is this really brilliant piece of engineering that's all about recycling wasted energy. So let's get right into it and talk about the turbocharger. So here's what we're going to cover. First, we'll break down what a turbo actually is and, how the heck it works. Then we'll get into the different kinds of turbo tech out there. After that, we'll look at the common ways they can fail, and this part's really important. We'll talk about how you can take care of them. And finally, we'll wrap up with a peek into the future of this amazing technology. All right, let's start at the very beginning. What's the main idea here? What problem was the turbocharger even invented to solve? I mean, this is the big question in engine design, right? For years and years, if you wanted more power, the answer was just make the engine bigger. More cylinders, more displacement. But that also means heavier car and, you guessed it, terrible gas mileage. There just had to be a smarter way to do it. And here it is. This is that smarter way. A turbocharger is basically a super efficient recycling machine. Think about it. It takes all that hot, high-pressure exhaust that's normally just wasted out the tailpipe and it puts it back to work. It uses that energy to cram more air into the engine. And the formula is simple. More air means you can burn more fuel, and burning more fuel means, boom, more power. But here's the thing. It's not just about going faster. The benefits are actually huge. Because turbos let you use smaller, more efficient engines, you end up with way better fuel economy and lower emissions. They also give you better torque, which is that punchy, responsive feeling you get when you step on the gas. They even make the engine quieter. And get this. They're a massive help at high altitudes, where the air is thin and engines usually struggle. Okay, so that all sounds pretty great in theory, but how does it actually do all that? Let's take a look under the hood, so to speak, and see how this thing is put together. This picture is perfect. It shows you the two halves of the turbocharger's personality. Over on the right, in red, you've got the hot side. That's the turbine. This is where all that fiery exhaust from the engine comes rushing in. And on the left, in blue, you have the cool side, which is the compressor. It handles the fresh, cool air going into the engine. They look like two separate things, but they are completely connected. The whole process is just this beautiful, self-sustaining loop. Okay, so follow me here. Step 1. Hot exhaust gas blasts out of the engine and spins that turbine wheel. Step 2. That turbine is connected by a solid shaft to the compressor wheel on the other side. So as the turbine spins, the compressor spins right along with it. Step 3. The spinning compressor acts like a jet engine in miniature, sucking in fresh air and squeezing it down, compressing it. And finally, step 4, all that compressed air gets forced back into the engine. It's basically a self-powered air pump, all running on energy that would have just been thrown away. Now, to really appreciate what's going on, you have to understand the speeds we're talking about. To create all that pressure, what we call boost, that little shaft and its wheels can spin up to, are you ready for this? 250,000 RPM. 250,000 rotations per minute. That is insane. It's more than 4,000 rotations every single second. It's just a mind-boggling piece of precision engineering. So just to quickly recap the main components, you have the turbine section, which captures the exhaust energy. You have the compressor section, which pressurizes the fresh air. And then, holding the whole thing together is the central housing. And this part is absolutely critical. It's what holds the shaft and the bearings that let it spin at those insane speeds. It's also got all these tiny passages for engine oil to flow through, which is crucial for keeping it lubricated and, just as importantly, cool. Okay. So the basic idea is genius, right? But it's not quite a one-size-fits-all kind of deal. Over the years, engineers have come up with different twists on the design to make turbos even more efficient and responsive, no matter how fast or slow the engine is running. Two of the most common types you'll run into are the waste-gated turbo and the variable geometry turbo, or VGT. The waste-gated one is the simpler, more classic design. Think of it like a pressure relief valve. It just has a little flap that opens up to let some exhaust bypass the turbine, which keeps it from overspeeding. The VGT, though, is much more sophisticated. It has these tiny adjustable vanes inside that can change their angle on the fly. This lets it control the exhaust flow much more precisely, giving you a quick response when you're driving slow and maximum power when you floor it. Now, with parts spinning at hundreds of thousands of RPM and dealing with crazy high temperatures, you'd think they'd break down all the time. And sometimes they do. But what's really fascinating is why they fail. And this chart tells a really interesting story. The turbocharger itself is actually incredibly reliable. The vast majority of failures, a whopping 90%, are caused by something else going wrong. About half of all failures are because of lubrication problems, issues with the engine oil, and another 40% are caused by some kind of foreign object getting sucked into it. It's almost never the turbo's own fault. So let's talk about that 40% first. We're talking about physical damage from something solid hitting those super delicate, fast-spinning wheels. And yeah, the results are, well, they're not pretty. As you can see here, it is absolutely catastrophic. And it really doesn't take much. A tiny little nut, a scrap of a gasket, maybe a bit of carbon that broke loose inside the engine. Anything like that can cause this kind of damage. When those fins are spinning at 200,000 RPM, they're incredibly fragile. The impact just shreds them to pieces. All right, now let's get to the #1 killer of turbos, problems with the engine oil. You have to remember that oil is doing two jobs at once. It's lubricating a shaft spinning at warp speed, and it's also carrying away a ton of heat. So what happens if that oil gets dirty or contaminated? Well, it basically turns into liquid sandpaper. This image here shows you exactly what that does. You can see these deep scores and grooves that have been ground into the bearing surfaces by tiny abrasive particles in the oil. This kind of wear creates wobble, and eventually the wheels will actually hit the inside of the housing. The other big enemy is heat. Let's say you've been driving hard, and you pull over and immediately kill the engine. Well, the turbo is still glowing hot, but the oil stops circulating. That oil just sits there inside the super hot central housing, and it literally cooks. It bakes into these hard carbon deposits. We call this hot shutdown. And those deposits can clog up the tiny oil passages, starve the turbo of lubrication, and cause it to seize up completely. So here's the good news. Since most of these failures are caused by outside problems, it means they are almost entirely preventable. So let's run through a few super simple habits that can make sure your turbo lives a long, happy life. Honestly, these 4 rules right here will prevent almost every common failure. First, the warm-up. When you first start the car, just take it easy for a minute. Let the oil get flowing properly to the turbo before you accelerate hard. Second, and this is maybe the most important one, the cool down. Let the engine idle for about 60 seconds before you shut it off. This prevents that hot shutdown we just talked about. And of course, the other 2 are no-brainers. Use the high-quality oil your car's manufacturer recommends, and make sure your air filter is clean so the turbo is breathing clean air. That's it. It's really that simple. Now, this basic technology has been around for a long time. But believe it or not, it's about to take its next giant leap forward. And it's all thanks to the move toward electric and hybrid vehicles. And this is the real game changer, the e-turbo. What they do is add a tiny, high-speed electric motor right onto the turbo's main shaft. Now, this does 2 incredible things. First, it can spin up the compressor instantly, which completely gets rid of any turbo lag. But here's the truly mind-blowing part, and this quote from Garrett Motion says it perfectly. It can also work in reverse. The exhaust gas can spin the motor and generate electricity. It becomes a power generator, helping to recharge the vehicle's battery. It's brilliant. So, you see, the turbocharger is evolving. It's going from being just a simple air pump to being a really sophisticated energy management system. It's not just about making power anymore, it's about smartly creating and recapturing energy. So that leaves us with a really fascinating question to think about. As these smart boosting systems become more common, how are they going to completely redefine what we think is possible when it comes to both performance and efficiency?